So how does this relate? How do you solve kinematic problems, problems involving numbers, with things that are undergoing acceleration due to gravity? Because when I read this problem, a person throws a ball straight up in the air, they catch it 3 seconds later. How high did the ball go? I feel like there's not enough information here to solve this problem. Step 1, remember, draw a picture. Step 2, list what you know. So I'm going to say that this ball goes up and then it comes right back down, and they catch it. And so they are throwing it and catching it. I'm going to say that that means that the starting height and the ending height are the same, and I'm going to call that 0 meters. Okay. So draw a picture, and then which way is positive? Well, up. Up is positive. I'm always going to make up positive as long as I can. Okay, second step is to list all of our variables. So that's the initial position, the final position, the initial velocity, the final velocity, the acceleration, and the time that it's spent in the air. When I look at this problem, it seems as if the only thing that I've been given is the time, right? So they catch it 3 seconds later. So this 3 seconds, that's our time. But the question is, how high did the ball go? It's not having to do with anything about when it hits the ground. And so I don't care about the time that it takes to go up and come back down. I care about the time that it takes to go up. And so the tricky part about some of these problems is that you might be given information about a whole set of motion, but you only really care about half the motion. We don't care about up and down. We only care about up, right? Because we want to know how high did it go. We want to know the final position if the initial position is 0 meters. And so if I'm talking about the time that it takes to go up, well, if it takes 3 seconds to go up and down, it spends half the time going up and half the time going down. And so the time is not 3 seconds. Even though it says it is, the time is actually 1.5 seconds. Now, this is thrown with some initial velocity. We don't know what that is. But what would the velocity be at the top of its motion? This is why we spent all of that time with graphs and understanding motion of objects before we got to the math. Because at this point, you guys should recognize that at the top of the motion, the velocity of the ball will be 0 meters per second. That leaves us with figuring out what the acceleration is. Well, the thing that's pulling on the ball is the Earth. The force is gravity. So this acceleration will be opposite g, negative gravitational field strength, or negative 10 meters per second squared. That will be our acceleration. So we listed our variables, we found what we were looking for, now we just need to pick the equation. So here's our velocity final is velocity initial plus acceleration times the time. That doesn't have anything to do with final position, not helpful. We've used this one before. Also not helpful because really the only thing we know is time, even though, so like, I don't know I don't know the initial velocity. So I can't use that one. That's not helpful. And so it's this guy. The change in position is the initial velocity times the time plus 1/2 times the acceleration times the time squared. And I know you're wondering to yourself, Dr. P, like this has the initial velocity in it and we don't know what that is. Oh my gosh. Oh my gosh. Okay, so when you run across this, which will happen all of the time, come back to this. right? Come back to this. The ball goes up and it comes back down. The velocity with which it's thrown here is going to equal the velocity with which it's caught down here. It takes 1.5 seconds to go up. It takes 1.5 seconds to go down. It travels the same distance. So why do I care if this is my initial and this is my final, or this is my initial and this is my final? So if we switch this around, and instead of thinking about this as a first half problem, the ball goes up, we think of it as a second half problem, the ball goes down. It takes 1.5 seconds for the ball to fall back to its original spot. And in that case, our initials and finals will switch. So I'm going to go ahead and put this in orange. So when you look at it as a second half problem, the initial position, you don't know, that's the highest height. But the final position, you know it ends at a position of 0 meters. We know my initial velocity now, this is the velocity at the top. That is now 0 meters per second. And the acceleration stays the same, negative 10 meters per second squared. And the time will also stay the same, 1.5 seconds. Now that we know this, that means this term right here will be 0. And then the only tricky part about this is this delta x, your displacement. The ball is now traveling downward. The displacement will be negative. I'm just going to go ahead and call this negative h, negative the height, because I want you to see what happens here. So this is 1/2 a, but the acceleration is negative g, t squared. I can cancel out a negative on this side and a negative on this side. I multiply both sides by 2, and then I divide both sides by 8, g, t squared. So this always holds, Dr. P. This always holds to find the time. Oops. So this always holds to find the time. This equation, you don't have to memorize it, but it should be something that is familiar to you. So I'm going to come back up to here when we were talking about this is negative h. So our height is, again, 1/2 negative g t squared. So we can just put in our information, our numbers, that was positive 1.5 squared, to find the height. Now again, I don't really care if you can plug this into your calculator. The important part here is that we've dealt with our negatives, this negative and this negative canceled out, and so the height will be positive. That's all I care about. So the big takeaway of this is if you get to a place where you're stuck, look at the problem again. You can think of this as a first half problem, up, a second half problem, up and down, or a third half problem, not a third half problem, or a total problem, up and down. And so if the question, instead of how high did the ball go, if the question was how fast was it thrown, you can look at that by doing up, down, or the whole time up and down. If you think of it as the whole time, this idea of this velocity is this opposite velocity is really important. And so if v final is negative v initial when it goes up and down, then you can use this equation right here because you know the acceleration, you know the time, and these two values would be the same. So if v final is negative v initial, negative 10 meters per second squared times 30 seconds. This comes to the side. Don't forget when you do this that it becomes negative, so they don't cancel. You get negative 2 times the initial velocity. And then we divide both sides by negative 2. So we get the initial velocity is going to be 15 meters per second. So that's a pretty easy problem to do as a whole problem. But it would be even easier if you thought of it as a half problem, right? If it goes up or goes down in 1.5 seconds, and the acceleration is 10 meters per second, acceleration times time is your velocity if one of them is 0. Oh, cool. All right.